Good morning, everybody. Ah, Pedro's already there. Good morning, Pedro. Um, yeah, welcome back to Coding on Swiboe, the next generation text editor. Yesterday we were starting to building a C client so that we can build a Python client so that plugins can be written in Python. And once we have a C client as a shared library, it should be very simple to also make a plugin, for example, like a plugin editor for um, I don't know, other languages, for example, Ruby on Rails and JavaScript or something like that. Oh, and Objective-C, of course, because we want a beautiful macOS X GUI eventually. Yeah, but before we go about that, I would like to show you what I was working on yesterday evening. So actually I decided that I try to keep the streams consistent. So basically I do not want to make a lot of progress on the stuff that I was talking about on stream so that you guys have an easier time following. So yesterday evening I was actually working on something else, and that was making Swiboe not only work over Unix domain socket connections, but also over TCP connections. And that is actually why macOS X is now asking me if it's fine that the application is listening to network connections, because it does now, right? Basically, if I run a nmap, which is a network scanner, and I scan myself at the port 5555, it will actually tell me, wow, this is open. So I can now connect to Swiboe over like I run the terminal GUI, and instead of a path to a UDP socket, I just give it a address, and that should work too. So now I'm connected, and it looks very much the same as it did before. It is just running over TCP. Why is that important? So it is really cool because it means that we can run Swiboe on a remote host. So here in this red terminal here, I SSH'd into my server that I have where my homepage is hosted on, which is not in my house, somewhere on the internet. And here I actually now can run Swiboe. And I actually built a SSH tunnel from my local port 9000 to this particular computer, or to the port that Swiboe is listening on. So basically, if I now connect to my port 9000 on my local machine here, it looks like I'm connected to something, and if I now run that, you can see that it's actually just listing files on my remote machine. So like home server, you can see that must be Unix, because under macOS X, home is called users for some reason, and we can just open files, and we can navigate around those files. So like it's working really, really nicely. There are a couple of issues still. So first one is that, for example, for listing the directories, I had to hardcode a path here, because the completer widget in the terminal GUI right now is set up to actually list the current directory of the client. There's even a to-do for that here. And that is of course wrong. It should always use the current directory of the server, so that you get the files that the server sees. Or maybe not the current directory, but there should be some state on the server that says which directory we're working on. And also this feels a little sluggish. So if I press the key, it will actually, I would say it takes like 50 milliseconds or so until the cursor actually moves. I believe this is due to nagling. So Nagel's algorithm, which actually bunches up TCP packets, which was used in the old days to combine a bunch of terminal presses and send them over the network together, but is still the default on most machines these days. And I didn't disable that for TCP connections in Swiboe, but we definitely want to disable that, because we want low latency, and we don't really care if more data is sent over the network. Yeah, so this is not yet quite ready for prime time. There are a lot of like clunky hacks still in here. Not a lot, but some that need some cleaning up. For example, the port right now is hard-coded, and that it's listening on on TCP is also hard-coded. It should only listen on TCP when you actually request it to. This one here is hard-coded. I have to revert that again. So this is not quite ready, but it's working, and I will clean it up today and then merge it in, and then you guys can play around with it tomorrow. Okay, back to what we wanted to do today. Actually, what did we want to do today? So, let me just bring up the Swiboe page here. Uh, oh, hi Pods. Nice for dropping in. Guys, I have 2 live viewers this morning. That's really awesome. That's like more than I ever had before. So, what did we do yesterday? I think I actually merged in our work from yesterday. First test of getting data from Python to Rust. Perfect. So, where was that? Where was this code? Where was it? Where was it? Where am I? C client. We had this Python file, which we moved here. And then what else did we have? What else did we have? In the C client, we also had, I guess, a Rust file. Yay, there it is. Right, so what did we figure out? We already figured out how we actually call a Rust function from Python. We also figured out how we can pass through UTF-8 characters in a string, which is that's usually the ugly part. If you build any foreign function interface, it's always hard to how to get the strings from A to B. So I'm really glad about that. Now I would like to try out the other way around. So basically I would like to pass a Python function to Rust so that Rust can actually call back that Python function. That is important, for example, if you want to register an RPC call, then of course this RPC call has to be defined in Python if you build a Python plugin, so we need to call Python from Rust. And I have no idea how that will work. Basically, let's leave our wonderful hello world function here, copy it below, and then we actually make a new one and we call it hello1. All creative this morning, hello1. And what does it take? It should take some sort of function. It should take some sort of function, but I have no idea how you would tell Rust that. So let's Google for that. Rust C function, maybe? Foreign function interface. That sounds good. Foreign function interface. So what do we have? Extern function like that? No. No. Is there something about callbacks in here? Callbacks from C code to Rust functions. That sounds like what I want. I will callback from C with value 0. Excellent, this is what we want. Here, there it is. There it is. Sure, write it. Basically, so we have a hello1 function, and that should take a, why not just make it like that, right? We take a callback function that takes an integer 32, and then we call it. Print line in Rust, and here back in Rust, right? And here in between we call this function with 42. What's up? Oh, it's not called function, it's called callbacks. Nice, nice, nice. And now, of course, I can define a function for a callback here in Python. So we define our callback function here, and that takes one argument, and it will print that out, right? But how do I pass that now? So if I just call hello1 callback like that, that will never work. I have the feeling that this will not work. Because I don't think it will work, because actually, I mean, callback is a Python function object, which is a far shot from a C function, right? So there has to be some conversion layer in between, and I think that probably C-types helps us out with that, but yeah, I'm not sure. Let's wait till it compiles and then we run it and then we watch it crash. In the meantime, I can try to figure out how Twitch is showing the... Wow, I was lying. Guys, we have 4 viewers this morning. Hey Laszlo, I was stalking you yesterday. Are you the guy who wrote that this algorithmic drawing tool? I saw some YouTube videos in Swing. If so, that is pretty awesome. I really like that very much. And have you considered writing a Swift GUI for Swiboe? Because that would be awesome too. So, done compiling. Let's run it here. And what does it say? It says invalid syntax. Invalid syntax? What? Oh, Python 3. Right. In Python 3, the print keyword is actually not a keyword. We don't need this one anymore. Go away. It is actually a function, right? So back to Python 2, and now it should work. And what does it say? Don't know how to convert parameter 1. Okay. So back to Googling. We actually want C-types, Python. Yes. That should be like something very straightforward, right? We basically have to we have to define it, what sort of function that actually is. And I remember I did that before, and I think there's something like we can define we can set parameters for this function, and then here that's what we want. Like we want to say the argument types is whatever, and then we also have to tell it what the return type is. So, but I don't think we need that for now because we don't have a return type, but we can basically say, so SV hello1 archetypes will be actually, yeah, but how do you define a function like that? Right? Because our argument type is a function that takes a integer 32. So how do you make that? How can I like deal with that? Structures or unions, bit fields, arrays. Laszlo asks, a GUI for what? A GUI for this editor we're writing here. That would be cool, right? We have the terminal GUI, and I actually looked a little bit in doing a Cocoa GUI for Swiboe, and it shouldn't be that hard once we have an Objective-C client that can connect to it. And I would really love to have that, right? Like here in the back, you can see that is a Cocoa GUI for Vim, and it's really beautiful and it's much faster and it has more features. But having a Cocoa GUI for Swiboe would be even better. Did I now scroll over that? How do functions work? Jesus, callback functions. Callback functions. Yes, yes, please. How does it work? So our callback function receives pointers to integers and returns. First, we create the type for the callback functions. Okay. Really? Like that? So basically we say our callback type is a C type, C func type that takes a C int 32, like so. Undefined variable C in 32. Right, that must be somewhere in C types. And like so, right? And then we just say our callback function is of type callback, so like so. Like so. And that should work. Callback takes exactly one argument, 0 given. callback takes exactly one argument, 0 given. I'm confused. Back to the documentation. Why doesn't it like it? Oh, the first is the return value. So actually the return value is C types void. Oh, one word. C types void. It's actually not a C void pointer, gentlemen. It is just void. Why is it not working? Whoa, it did work. Guys, it worked. So it likes a C void pointer, though our function is not returning a C void pointer, it is returning nothing. Can I just put a none here, maybe? That would be more correct. Yeah, that works. It returns none. Perfect. Look at that, guys. We are in Rust, then we call it when the argument 42, and then we're back in Rust. Cool. Cool, cool. Let's return a value, just for like interest. Basically, our function now returns a string. Hello again. And that means that our return value here is C types C char pointer, right? Like so. And then we can do this whole game here again. Basically, we call our function and that will return us a C buffer. Our function now returns a const pointer to a C char. And so we call the callback with 42. We can actually incorporate the argument in the string, like so. And yeah, we return that, we get the function pointer back here, and then we convert it through this really complex argument, and then we can print it out. And now we basically should be done. Memory leak in callback function. How do you know? Also, who says that? Memory leak in callback function. Well, does it even work? Oh, I didn't compile. Jesus. So it still complains about memory leak in callback functions, but at least it works, right? Here we're back in Rust and we print out the hello again 42. But why is it actually complaining about a memory leak? So if we get this value here, do we actually own it? Apparently we own it. So we have to free it, I guess. So what is cstring from pointer doing? That is what I'm interested in right now. Rust nightly cstring. So basically it says representation of a borrowed cstring. So I guess it is true that we actually don't own this string. So what is the other one? It's cstring. Oh, that's really nice. So str is an unowned string in Rust and string is an owned string in Rust. And for cstring they have the same types. Creates a new C compatible string from a container of bytes. And rename to from raw. That's what we want. We want a unsafe from raw that takes a C string. Great. It's just that it worked. Look at that, guys. Like this one is deprecated from pointer. We should use from raw. And from raw is still not yet working. It's unstable. Well, it's working, but it's unstable. So we don't want cstr here. We actually want cstring because we take ownership of the string that we get returned from Python. And I think that should probably be it. Not make, cargo. Cargo build. Use of undeclared type name cstr. Oh, I shouldn't. shouldn't remove it, I need both, right? C_str and C_string. Use of unstable library feature, sys_str memory, rename from blah blah blah. Add feature sys_str to the crates attribute. Yes, we will do that. So we put this at the very top to tell the compiler, yes, we know that this is an unstable feature, but we really want to use it. And it compiled. Now let's see if it runs again. Whoa! Crash. Crash. So it doesn't work. Why doesn't it work? Oh, that's why it doesn't work. Wait, what? No. What? So here we create a string and we say we now we own those bytes that we get from Python. And then we convert them to a byte slice, and then we construct a string slice out of that. That seems all fine. So only this one should actually own the memory, but it seems like Python is disagreeing. It is not like it doesn't. It is actually convinced that we don't own. Like we have a double free now. That is what I'm essentially saying. So basically, Python claims that the pointer being freed was not allocated, and the only pointer we're freeing is this one, right? So basically, if we revert that again, and instead of C_str from raw, we use C_string from raw, which is not called C_string from raw, but it's called C_string from pointer. And then it runs again, but we have this runtime memory leak and callback function. What does that mean? Let's Google that real quick. What is it that ctypes wants to tell us? So there's a test. Let's have a look at test. When is it actually bringing this up? And how does it know? A callback function cannot return a non-integral ctype without causing a memory leak. Well, that's an important information. Okay. So what's the correct way then to pass a pointer back, a string from Rust to Python? Do I actually have to take, basically if I here don't take an integer, but I take, what do I take? I mean, how do I pass a pointer back? Basically if I say if I return a char pointer, it's not happy with that. What is if I pass as second argument a pointer to a char pointer, right? And then this here returns none again, right? We don't return anything. But instead of an integer, we now also take a pointer to a pointer of something like that. And it's complaining because I didn't, I should likely use like a mutable pointer to a pointer. Wow, that reads weird. So the function now takes a mutable pointer to a const cchar pointer, and it returns nothing. So basically, we now have in our callback function But we cannot assign to that, can we? Basically, if we now take here that is like our Swiboe pointer or something like that, if we now say Swiboe pointer is this won't work. I mean, will it? No, I don't think so. But we can try it out. We can try it out. We basically what do we do? Like we need a mutable pointer, libc c char pointer, right? Like so. And that is our type. So we say pointer is this, and then we pass it to the function as mutable pointer. That won't even compile. I cannot believe that compiles. That mutable goes here and like so. Yeah, see, it doesn't like that. Yeah, I don't know. I'm a little bit stuck here. I guess I cut the stream here, and we'll look into that tomorrow. I really have to figure out, basically, like if we can figure that out, we have everything that we need for a proper foreign function interface. We can like pass strings from Python to Rust, which we do up here, unowned strings, and if we can pass callback functions, that was remarkably easy too, with like this ugly syntax, but who cares, as long as it works. And now the last tricky thing is passing a string back to Python and transferring ownership of the string, doing that. And yeah, like apparently the simple solution that we tried first by just returning a pointer to a C string doesn't work. Apparently Python is not taking ownership of that, and then we leak the memory, which is not good. So there must be another solution, but the ones that I came up with right now are not working. So I have some reading to do, and then tomorrow in the stream we will continue on. We'll continue on exactly where we left off today, I hope. Okay, guys, thanks for watching. Talk to you. What's tomorrow is Saturday, so I'll probably not stream on the weekends. So I'll talk to you guys on Monday.